Key idea that Dr. Feldman-Barrett has contributed to studies of the anterior mid-cingulate cortex as a structure that helps us generate what we call tenacity and willpower to help us achieve different types of goals is this idea of allostasis. Most of you have perhaps heard of homeostasis, which is the idea that all of our cells, all of our organs, indeed our entire body and psychology are always seeking homeostasis, the perfect balance of sleep and activity, of food and burning fuels, of oxygen and carbon dioxide, and so on and so forth. And while homeostasis certainly exists and is a valid phenomenon, there's also a concept that we hear far less about, but that is equally important, which is the concept of allostasis. Allostasis is the idea that much of what our brain and body need to do, but especially our brain, is to allocate, right? Allostasis, to allocate resources to particular functions depending on our motivational goals and the challenges upon us. And in every way, what we understand about the structure and function of the anterior mid-cingulate cortex is that it is doing just that. It is deciding how much glucose should a given brain area consume. Perhaps a brain area that's involved in visual perception because you're involved in a motivational task where in order to succeed, you need to pay careful visual attention to particular things. Or you're involved in a task where you have to listen to particular things. Or perhaps you are involved in a physical foot race where you don't want to allocate a lot of energy towards thinking about your stride or your step unless that's necessary, and you actually want to shut down your brain activity as much as possible, except for the brain areas that are required to get you to continue to run. In that sense, the anterior mid-cingulate cortex, as a sort of a dial on how much fuel is consumed, not by the brain and body as a whole, but by individual brain and body parts, meets all the criteria of what you would want for a brain area that controls things like tenacity and willpower. Because even for those individuals who seem to just have an endless supply of tenacity and willpower, they too have to go into habitual behavior. They can't simply lean into every aspect of life with the kind of resistance from outside and the resistance against those outside forces, or even resistance to internal forces, voices in their head, etc., on a constant basis. They still need to sleep. They still need to be functional in that expression of tenacity and willpower. They need to be able to strategy switch, and they need to be able to come off the gas, as we say. Not because tenacity and willpower are necessarily a limited resource, but because for so many aspects of life, engaging tenacity and willpower is not advantageous. Hence the example I gave earlier about eating disorders, where an apparently hardwired function of our brain to be able to generate some sort of reward for resisting a given behavior goes too far and then can actually threaten one's own health or even life. So the concept of allostatic load, allostatic balance, and allostatic function is something that we get into in a fair amount of detail in the discussion with Dr. Feldman-Barrett in that episode, which is coming out soon. But in the meantime, if you are to think about the anterior mid-cingulate cortex as having a single function, the function that Dr. Feldman-Barrett has ascribed to it as controlling how much energy different brain and body areas should get in a given context, well, that makes a lot of sense to me, and I think it's the one that best describes all of the functional data, indeed includes or jibes with all the anatomical data about the anterior mid-cingulate cortex as well. One of the really important twists in all of this is that the anterior mid-cingulate cortex is not just sitting there to allocate and dole out different amounts of energy and activation to different brain areas. It is also receiving input from both the brain and body. And in sort of a beautiful twist on the whole story of what the anterior mid-cingulate cortex does, we know that when we move our body, we are activating the anterior mid-cingulate cortex. And we know that when we move our body because we in some way forced ourselves or encouraged ourselves to do it, we activate the anterior mid-cingulate cortex more. Similarly, and because the anterior mid-cingulate cortex is so flexible in the different contexts in which it can be activated, if we are simply reading, or we are listening to something that we're supposed to learn, or trying to learn a piece of music, or trying to do anything for that matter, the anterior mid-cingulate cortex, yes, will be activated, but that its levels of activation are far greater when we experience a lot of resistance that we have to overcome.